All right, this is our video from Monday, April 27th, pre-cal. We are going to start talking about Chapter 8 today. Spend a little bit of time here. Specifically, we're going to spend this week in Chapter 8, Section 1. And today we are going to have our introduction to sequences. Tomorrow we're going to take some sequences and try and figure out their explicit formula. And today we'll find out what explicit formula means. Wednesday we're going to talk about factorials, which are pretty fun. And Thursday we're going to talk about summations, which are important if you're going to head into calculus. And all of the work that we're going to do is going to be due Thursday night at midnight. And we'll have a quiz on 8.1 on Friday. All right, so we're going to start with a few definitions, and you should have your books open to page 556. And first of all, we're just going to talk about what a sequence is. And a sequence is a set of numbers in a specific order. There's a reason why these numbers are together. And because there's a reason, there's usually a formula behind it. And today we're going to learn about two different types of formulas that you could have. But a sequence is basically just a set of numbers in a specific order. Each sequence has terms. So terms are the numbers in a sequence. You can have an infinite sequence, which just means it goes to infinity, that it never stops. But you can also have a finite sequence, which means that it has an end. Has an end, just a set number of terms. So when you're talking about a sequence, they love to use the lowercase letter a to represent the different terms, and then they put subscripts. So they might say a sub 1 for the first term, and then a sub 2 for the second, a sub 3 for the third, and they love to use a sub n for the nth term. And on a lot of ACT tests, they'll say, what is the nth term of the sequence, or what is the 27th term? And they want you to figure out what was the 27th number in this particular sequence. And so if you look in your book on page 556, you'll see example 1. And it says, write the first 4 terms of the sequences given by, and they give you a formula. Okay, this is actually called, this is where you can write it, an explicit formula. And it can be used to find the nth term of a sequence. Or it could actually be used to find any term of a sequence. And that's going to be important later. Here, though, they just give us the explicit formula. So this is example 1, part A. They tell us a sub n is equal to 3n minus 2. And they want us to find the first 4 terms of the given sequence. So they want the first 4 terms. All right. So the first term, we would have n is 1. And so we would put in 1 for the n value. And 3 times 1 is 3, minus 2 is 1. So the first term is 1. And then for the second term, we would put in 2 for n. And so we'd have 3 times 2 minus 2. 3 times 2 is 6, minus 2 is 4. So 4 is our second term. For our third term, we're going to put 3 in for n. And 3 times 3 is 9, and 9 minus 2 is 7. So 7 is our next term. And our fourth term would be 3 times 4 minus 2. 3 times 4 is 12, minus 2 would be 10. And that's all they want. They want the first 4 terms of our sequence. Now, if you look at this, you'll see that they're actually adding 3 each time to get the next number. And if you know the term in front and you just want to add 3, that's called a recursive formula, and we'll talk more about that in a minute. All right, on part B, we have the explicit formula a sub n is equal to 3 plus negative 1 in parentheses to the nth power. So for the first term, we're going to put in 1 for n, and negative 1 to the first power is negative 1, and 3 plus negative 1 is 2, so our first term is 2. For our second term, we're going to put in 2 for n, and negative 1 squared is 1, plus 3 is 4. So our second term is going to be 4. For our third term, we are going to put in 3, and we get negative 1 to the third power is negative 1, plus 3 is 2. So this is an interesting little sequence. Next, for our fourth term, we're going to put in 4, and we get 3 plus 1 is 4. And so this would be repeating 2 and 4, 2 and 4, depending on what term you were looking for. And so this is an explicit formula for a sequence, and they wanted us just to plug in and find the first 4 terms. So it's called explicit. All right, now I want you to turn to page 564. Excuse me, let's start with page 563. And so when you look at 1 through 20, you'll see that this time they want the first 5 terms, assume n begins with 1, and then they want you just to do what we just did right here. So again, they're just giving you the explicit formula. You plug in the number of the term and do that for the first 5 terms. All right. Now, on page 564, let's look at number 53. And it kind of has a strange, let me see if I can make some adjustments here. Okay. So it says, write the first 5 terms of the sequence, but it gives you a strange formula. So it tells us that the first term is 28, and the formula a k plus 1 equals a sub k minus 4. And they want the first 5 terms. And it says, of the sequence defined recursively. All right, so this is called an explicit formula. And it can be used to find any term. Like if we wanted the 20th term, then we would just plug in the 20, and that would be even, and so that answer would be 4. So the explicit formula can be used to find any term. Okay, this is called the recursive formula. And the recursive, it kind of helps you to see what's going on, but it's not real helpful if they want the 100th term. So when we look at this, this is a sub k, and this is a sub k plus 1. So a sub k would be in front of a sub k plus 1. So we know the first term is 28. So if we were looking for, if we have a sub k is a sub 1, and then 1 plus 1 is 2. So if we're looking for the second term, we're going to take the first term and subtract 4. So 28 is the first term, and 28 minus 4 would be 24. And if I want the third term, so that would be 2 plus 1. So I would need the second term and subtract 4. and I would get 20. And really, what the recursive does is it's just showing you what's happening to get the next term. And so if you know the term in front, you just need to subtract 4. So over here, the recursive formula for this one is that they were adding 3. And so if you know the term in front, you just add 3 to get the next term. And so this would be 13, 16, 19. But then they ask you what was the 100th term, you'd have to write it all out. So the recursive can kind of tell you what's happening to get the next number. But if they ask you for a specific term on down the line, it's not that useful. That's why we like the explicit formula. Explicit can be used to find an exact term. The recursive, what's a good way to say that? It tells you what is happening to get the next term. So they're both important. This one is better if you're asked for a specific term. This is better if you just want an understanding of what's taking place. So they wanted 5 terms. So the first term was 28, and we're just subtracting 4. So 28 minus 24 was 20. 20 minus 4 is 16. 16 minus 4 is 12. And these would be the first 5 terms of our sequence. So with the recursive, they're just kind of telling you what is happening to get the next number. If you look at 54, you're basically adding 3 to get each term. 56, you're taking half. And so this is just saying on 55, you're subtracting 1 and doubling. And so if you know the term in front, you can easily find the term right behind it, the one recursive, the one right behind it. All right, we're going to stop there for today, and we will come back tomorrow and find some explicit formulas. For today, I want you on page 563 to work the even 2 through 12, 22, 24, 54, and 56.